Big class today, huh? So let me tell you this. I graded the exams on Scantron, and if I left the exams as the score that they have, we would have like three A's in the class. So, is there a correlation to not showing up for class? And I mean, some of you who show up are the ones that are higher up, and you probably might get an A with partial credit. But in general, the class is slacking, and I'm making the tests easier and easier. So I'm going to go back to my old hard test. I'm not going to give anybody anything, and we're going to just have everybody in this class again next semester, okay? So maybe everyone can do better on the second time. But when I give you an exam beforehand, and you still can't do it, like I didn't change anything. Some people wrote down that they ran out of time. I gave you the exam with the exact length. Nothing changed. You need to start focusing on working on doing things to better yourself. And is showing up for class important? Yes. So should I stop recording lectures? Will that increase people showing up? I mean, I'm talking to you guys because you're here, but you're the ones who do show up. So should I stop recording lectures? I'm thinking starting next week, I might record them, but I'm only going to give them to people who give me real excuses because I'm sick of people being slackers this whole semester, okay? This is college. You need to show up for class. You need to learn stuff, all right? So thank you all for showing up. Make a sign-in sheet, and whoever's here will get us 2 points extra credit on this last exam since everyone did so bad. So Ella, start a paper, write your name, and we'll make sure. If anybody writes anyone else's name, I will give you minus 50 on the exam. Okay? So don't try and hook up your friend who's a slacker. If you're on Zoom, great, but you're not getting the extra credit, okay? There's literally, what, 20 people here? Out of 120, I get 20% attendance. Why do I even need to lecture? I know it's for you guys, so that's why we'll lecture. But this piece of paper is passing around. Those of you who are here, sign up, get some extra credit for this exam, which I'm in the midst of grading. And like I said, if I didn't give partial credit, which is annoying as hell to me to have to go in and give partial credit, okay? It wastes my time, and I don't think I want to do that anymore, okay? So think about that for this and the final. I'm just going to give you your score, and if you bomb the final, you're going to fail the class. So start coming to class. If you're watching this recording or you're on Zoom, start coming to class. It's pretty ridiculous. All right. Thank you for those of you who are here. So we talked about pH on Wednesday, right? pH is a measure of the amount of protons in a solution. We learned last class that you can calculate the amount of H plus and the amount of OH minus in solution by always looking at the formula H plus concentration times OH minus concentration equals 1 times 10 to the negative 14th, actually. 1 times 10 to the negative 14th. In neutral species, they both have a concentration of 1 times 10 to the negative 7th. When you multiply them out, they add up to 1 times 10 to the negative 14th. When a solution has more H plus than OH minus, that would mean the concentration is greater than 1 times 10 to the negative 7th. That means the OH is going to be less. And based on like Le Chatelier's principle, when one goes up, the other one goes down and things like that. That being said, on that last exam, I'm like going through and circling what people got wrong. I cannot believe how bad we did on Le Chatelier's principle, okay? That I thought was 5 free. That was 1/4 of the class of the test that I thought was like give me's. Le Chatelier's principle is the easiest thing in all of this class. And there was a lot of people who did not do well on it. So that either means you're not studying or you just didn't even, I don't know, whatever. I'm over that. I don't really get mad about people doing bad grades. I feel bad that people fail, but at the end of the day, I'm not the one who has to retake the class or go home and face the music. So try better. Those of you who didn't do well, I will get your exams back sometimes next week. If you don't do corrections, you're basically just saying you would like to fail this class, okay? So finding the pH, once we know the H plus concentration, remember H plus and H3O plus are 100% interchangeable. And I don't know how this paper is going around. Just make sure you sign it before you leave. If you come in late, I don't care if you sign it because you're coming in late. whatever the value is of H plus, you take the log of it, and then that's going to usually give you a negative number. So you just take the opposite of it, okay? So you don't really have to plug in the negative if you don't want to. Just do the log of the H plus concentration. It's going to give you a negative value. Know that the value should be positive, okay? So if we have the pH of pure water, when we said H plus equals 1 times 10 to the negative 7th, the negative log of 10 to the negative 7th equals 7. So pH 7 equals neutral water, which means that we have an equal concentration of H plus as we do OH minus, which is that 1 times 10 to the negative 7th molar. Okay? Now, if you know the H3O concentration, you can directly find the pH. Sometimes I'm going to give you the OH minus concentration. You will have to use that formula that I gave you, and that will be how you find the pH of a solution. We're going to learn that pH has a thing that's called pOH, which is basically going to be the same thing, just thinking about OH minus instead of H plus. And in this case over here, they're going to be all related. On Wednesday next week, I plan on having a little quiz to make sure we know how to use pH, pOH, H plus, OH minus, be able to convert back and forth with all of those. I would bring my calculator unless you're super good at doing logarithms in your head and things like that, which I can tell you, unless it's a 1, most people are not that good at logarithms, okay? So let's look at a problem. If I tell you a solution has a H3O plus concentration of 1 times 10 to the negative third, you take the negative log of 1 times 10 to the negative third, which gives us negative 3, or the log of 1 times 10 to the negative third equals negative 3. So the negative 3 gives us a pH equal to 3. Is 1 times 10 to the negative 3, is 1 times 10 to the negative 3 greater than 1 times 10 to the negative 7? Yes or no? Yes, it is. So that means that there's more H plus than OH minus. Does a pH of 3 correlate to the solution having more acid than base, which we would say is an acidic solution? The answer is yes. If the pH is less than 7, that means it's an acidic solution. So we don't always have to know exactly what we're going to get when we punch into our calculator, but we should have an idea of should the solution be acidic or should the solution be basic? Because if we at least know that, if we get a value that's out of that range, we know we did something wrong or we forgot to convert something or something like that. Correct? All right. With sig figs, like I said, it's great for sig figs. I don't look at sig figs that much in the homework and things like that. On the exam, I don't think I'll give you a question that's straight specific on sig figs, but just so you know, when you use an exponent, how many sig figs in this number right here, Jack? 2.0 times 10 to the 6th. It has 2. So is 2.0 significant numbers? Yes. When it's 0.0, that means it's significant. We do not worry about the times 10 to the whatever, okay? So the times 10 to the whatever is never included in our significant figures. If I give you a number like 711 times 10 to the negative 4th, how many sig figs in this number? Amanda? How many sig figs in this number? Very good. 3. You only look at this over here. How many sig figs in 8.72156 times 10 to the 4th? How many for this one, Valerie? 1, 2, 3, 4, 5, 6. Very good. So we only look at that beginning number. Now, when we do the log of that number, someone go ahead and punch this into your calc. Let's make it negative 4th, okay? Because if we do positive 4th, it's going to give us a super negative pH, and I don't think we're ready for that yet. You get this answer, Robert? Six 6.301 what? Is there any more numbers? Because technically we're supposed to have 1, 2, 3, 4, 5, 6 sig figs. So with pHs, the sig figs are the number after the decimal point, okay? The 6 does not count as a significant figure in sig figs of pHs and things like that. So if someone tells you there's a pH of 7.00, they're saying that's measured with 2 significant figures of accuracy. If they say it's a pH of 7, I mean, I guess that's 1 sig fig, but it's really not. That's just saying it's roughly neutral. But if someone told you it's like a pH of 7.1345, that's letting you know that they're measuring the concentration of H plus to 4 significant figures, okay? So with sig figs and logs, it's the number after the decimal place that represents the number of significant figures. That probably will not be important for like our tests and homework and stuff, but just as a general knowledge for you to know, that's good information to know, okay? So the sig figs are the digits after the decimal point in the log, okay? What do the numbers apply? Once again, pH 7 is neutral. H plus equals OH minus concentration, which happens to be 1 times 10 to the negative 7th molar in this case. This is from the autoionization of water, okay? Anything less than pH 7 is acidic. Anything greater than pH 7 we call basic. What's another word for basic? Anybody hear it before? Alkaline. Okay, so you might have heard of like alkaline water, and they say it has a pH of 8 or 8.5 or something like that. It's like a gimmick, and they say like it's better for you because it like neutralizes the acid in your body and stuff like that. Guess what your stomach's full of? A bunch of acid. And guess what happens when you drink a bunch of very, very lightly basic water? Nothing. It just neutralizes your stomach acid. Is it bad for you? I don't know that it's bad for you, but I don't know it's as good for you as they say. So when you have the choice of buying the $4 bottle of water or the $6 bottle of alkaline water, I'm using new tariff prices in my analogy over here, then you don't need to pay that extra $2 for the alkaline water. If that alkaline water makes you get rid of your hangover, it's probably a placebo, but if that placebo works, feel free to use that, okay? So those of you at home on Zoom, guess what? Go drink some water right now. It'll get rid of your hangover. Maybe it will. It probably will because you're probably dehydrated. Or come to class and walk around and sweat it out, okay? So as I said, the normal range for pH is 0 to 14. When you have a 1 molar acid solution, that correlates to a pH of 0 actually, which is kind of weird, right? So what that tells us is if you have like a 3 molar solution of acid, that has a negative pH. Most of the things we deal with are not in that. I mean, you're not usually dealing with like super, and when I say that's the weird thing, right? 10 molar HCl HCl is a strong acid, whether it's 10 molar or 0.1 molar. If someone says, I'm going to pour some acid on you, I'll let you choose which one. Would you choose 10 molar or 0.1 molar? What do you think, honey? The 0.1, right? Because it has less total H plus, and that's the stuff that's being corrosive. And I mean, why would anyone say that to you? Let's say they were going to pour it on your favorite Beanie Baby or something, or whatever else, your squishy, whatever you hold dear to yourself. I don't know what this age students hold dear. And I'm usually like 1 year or two behind all the trends anyway. So I just pretend like Beanie Babies are something that you do. What's the cool things everyone has nowadays? Anything? Nothing. Oh, your phone? Oh, let's just watch TikTok for the next 7 years and hope that we learn chemistry in between that time, right? Maybe put your phone down for a little while and do some studying more than a day before the exam, and will make your life a little easier. Or just hope that every single test of every single class is easy enough for you to just do it the day before. Let's calculate a couple pHs, okay? So first I want you to calculate the pH of this H3O plus. Second, I want you to calculate this pH of a OH minus. So let's take 4 minutes to do this. The first one should be really quickly. The second one, I will give you a little hint. You cannot find the pH directly yet from OH minus. Anybody have a hint on how to do this? This one, we're just going to do the negative log of that number. That'll give us the pH, okay? This one, we cannot do negative log of OH minus yet. So what will we have to do? Any thoughts on this? Ian? If I give you the OH minus concentration, how are you going to find the H plus concentration? Just being here is not good enough. You need to listen when you're in class. So what do you think you do? Is there any relation to OH minus and H plus? What is it? You got that correct. H plus times OH minus equals 1 times 10 to the negative 14th. If we have this value, can we plug it in there? Can we then solve for the H plus? Once we have the H plus, can we do the negative log of that H plus to find that? So that will be how we do this problem, okay? For the first one, we just do the negative log of the H plus, which is 1.8 times 10 to the negative 4. On the second one, you have to do some roundabout mathematics, okay? So these things, you want to like start writing down important equations for your note sheet. You think this is an important equation for this note sheet? What do you think, Bailey? You're going to just memorize that? You could. It's not that hard of a thing to memorize, but what happens when you've been cramming all night, sleeping for 3 hours before the test, and now all of a sudden you're like, damn, I knew this, but I didn't write it down. Start making your note card early. Anybody get an answer for the first one? How much? So we do the negative log of H plus for A. 3.8. How many sig figs did this number have? 2, so it was 1.8. So our answer should have 2 sig figs. So if it was just 1 sig fig in the 1.8 times 10 to the negative 4, 3.8 would be correct. The 3 does not count towards the sig figs. Yeah, Ella. No, in the pH, the first number doesn't count. So in the pH, it's the decimals after that counts. In the number 1.8 times 10 to the negative 4, that has 2 sig figs, right? So now when we write our pH, that 3 is just telling us which range of times 10 to the go to, and the decimal places after are the sig figs. So now that we got that straight, the answer should have, so this value here has 2 sig figs. So when you do a pH, that tells you the number of points of numbers after the decimal tells you what number of sig figs. So since this problem had 2 sig figs, we should put our answer with 2 sig figs. 3.8 only has 1 sig fig. That makes sense? It's just specific, oh, for logs. But yeah, so with pHs, with POHs, with pKs, all the things we're going to learn about that have logs, that's going to be the case. When you do a log, that first number is like just telling us which, it's like saying which decade you're in, and then you have to figure out the month and the year or something. I don't know. I don't have a good analogy for that, but that's the way you do that. Why don't they count the first number for pH? Because it just tells you it's multiplied by a factor of 10, and that's the reason why it doesn't count. I don't know. You know, there's this one real good resource that you could look up. It's called the internet, which is really just an AI bot telling you stuff. So look that up, and while you're chilling at home on your couch in your pajamas, tell me if someone gets that. Or while you're frantically playing on your laptop in the back corner, what does it say? Nate, what is it? Look that up. You got a computer, or any of you in the back with your computers. So the back rows for computers, huh? Front rows for listening. Maybe if we wanted to listen better, we'd come sit in the front and force ourselves to listen a little more. But I only make suggestions. You do whatever you do. I don't tell you how to live your life. The solution's acidic. Does that make sense that this solution is acidic? Natalie? How do we know that this solution should have been acidic? Very good. If this number here, well, this is acidic because it's less than 7. If this number here is greater than something times 10 to the negative 7. So is 1.8 times 10 to the negative 4th greater than 1 times 10 to the negative 7? Yes, Nana. It's H plus times OH minus. So basically what you do to convert this into, so to convert this OH minus into a H plus concentration, since this times this equals 1 times 10 to the negative 14, we're going to divide by the OH minus concentration, which is 1.3 times 10 to the negative 2, divide by 1.3 times 10 to the negative 2. That's going to give us our H plus concentration, which we can then plug into the thing. Ricardo, is this number here, not that number here, is this number here greater than or less than or equal to 1 times 10 to the negative 7? So what does that mean? Our OH minus is greater than 1 times 10 to the negative 7. Should our pH be acidic or basic? Yes. So since the OH minus is greater than that neutral solution, we should get a pH equal to basic, which means what, Cade? What range should it be from? I mean, it could be greater than 14, but yeah, it should just be greater than 7, right? So greater than 7. So when we do this, Nana, did you solve for it? Anybody solve for it? You got it, Robert? So we got 1 times 10 to the negative 14 divided by 1.3 times 10 to the negative 12 gives us 7.7 times 10 to the negative 13 for H3O plus. We do the negative log of that number. We get 12.11. The 12 would be with no sig fig. So, I mean, it tells us that it's basic, but the 12.11 makes it more specific. With pHs, I think next week we will be doing an experiment using pH meters where we're going to calculate the pH and things. And we got another formal lab report set up for that one. Maybe someday your lab professor will grade your formal lab report. I don't know if all of yours did, but ours is a slacker, whoever's in our lab. Or maybe I'm just waiting for everyone to turn it in. Let's go with that. Okay, I'm just kidding. Would you rather me grade exams or lab reports? I know, because most of you are not in my lab. So someday I'll get everything done, okay? You know, spring break's hard. You should be time to catch up, but guess what? Sometimes people don't do that. So is there any questions on how to do this? This kind of question will be on the quiz on Wednesday, most likely a Canvas quiz, but you will be able to work in groups, okay? Maybe though I'll make it so you have to come to class, so I'll only put the questions on the board for those students who pay attention. All right? But people are doing so bad, I can't make people get worse, so. Calculate the H3O. So let's go backwards now. This is another thing that could be on the test. What do you think we have to do for this, Kayla? So in this case, the pH is given, right? We just did H3O plus to find pH. Can we work backwards? What do you think? I mean, so if the pH equals the negative log of H plus concentration, and once again, H plus and H3O plus are the same, then if they give us the pH, can we work backwards to get here? What do you think we have to do in this case? Huh? We don't divide by, I mean, so we're going to divide by -1 to get rid of that thing. So it's going to be the log of H plus equals negative pH. Now you cannot divide by a log. There is a function that is basic. So like, you know how multiplication and division are inverses or whatever? If you have something adding, you subtract it. When you have a log, what do? Anybody know? It's not E. What is it? So E is what happens when you do natural log. So when you do a log, so the best way to look at it, everybody take your calculator out. Who has a regular calculator? You got one, Kobe? So you see the log button on there? You know how you can push second log? What is the little second above log? 10 to the X, okay? So the log of something is like the root base 10 of something or whatever that means. So basically what you do is you do 10 to the negative pH, okay? And 10 to the log cancels out the log. Okay? So because I've just done this recently, I knew it was 10 to the, but at the end of summer, I don't remember how log and 10 to the are related and natural log and e to the are related. But I just look at a calculator and I know that they put those two things because they're inverse functions of each other, okay? So let's try and solve for this. 10 to the negative pH would be 10 to the negative 4.80. Anybody get a value? Yes, Cade? 1.58 times 10 to the negative 5. Anybody else get that? You got that? You think that's the answer, or you think I put too many sig figs? What's our thought on this? How many sig figs did the pH have, Ella? How many sig figs did the pH have, Ella? We don't count that first number, so we should go 1.6 times 10 to the negative fifth. Let's see what the book did. 1.6 times 10 to the negative fifth. If you did 1.58 on our test, since it's multiple choice, I'm not going to have it like different answers with sig figs. You'd probably be able to pick the right answer out. If you're inputting an answer into Canvas, Canvas definitely does not understand sig figs, so it'd probably still give you the answer correct. But I just want you to know the sig figs for when you're on College Jeopardy and you're representing Sonoma State or whatever school you're at. Just kidding. And you do that, okay? So everybody see how to do this? Anybody not get this answer right here or this answer right here? Raise your hand. We can talk it out. Yeah? What'd you get? You got 0.0000158? Like 4 zeros and then the 158? So you're pretty close, but it should only be 4 zeros and then 1589. So we can talk about that after if you want. You're getting the right numerical value. You just have I don't know what it is that you did differently. Everybody else good with this? So we'll have to know how to do this stuff. Guess what? There's also something called POH. How do you think POH is related to this stuff? Any thoughts? All we're doing is measuring the OH instead of the H plus. It's exactly the same as pH, but we're now just finding it in terms of OH. How do you think? So this is showing us how the pH scale is related to the POH scale. So a pH of 11 is basic, right? A POH of 3 is also basic because we're now having more of that OH minus thing. So everybody looking at these numbers, tell me if you can find the relationship between pH and POH. Yeah, Jack. Very good. You see that? At 7, they're both equal. So 7 plus 7 equals 14. 1 plus 13 equals 14. 12 plus 2 equals 14. 11 plus 3. So the other thing you can do is, so what we're going to see is if you're given an OH minus concentration, you can just take the negative log of that OH minus concentration instead of converting to H plus like we did for that B of the last problem, right? That will give us a POH, and then you can just take 14 minus that number. That's what I usually do because I don't like working with all the times 10 to the negatives and stuff, and it just gives you more chance to like make a mistake when you're going from H plus to OH minus. Once again, it's all about what you feel most comfortable with. So once again, if you get a POH greater than 7, that's the opposite of a pH greater than 7. So a POH greater than 7 means it's acidic. A POH less than 7 means it's basic. The take-home message is pH plus POH equals 14. So if you find the POH, you can just do 14 minus the POH to get the pH. Let's go back to this other problem over here. So now instead of doing this problem the way we did with all of this, let's take the negative log of 1.3 times 10 to the negative 2. Who can tell me what you get here? 2.9? 1.9. So that will equal 1.9. If we do 14 minus 1.9, we will get 12.1. If we would have used the right number of sig figs, we probably would have got the exact same answer. But you see how we get the same answer. So whichever way you like doing better. Do you like doing the negative log of the value and then do 14 minus it? Or do you want to do this times this to find this number and then do the negative log of it? Like if you're more comfortable doing it the way we did first, do it the way you want, okay? You do whatever makes you comfortable. In chemistry and in everything in life, unless it's illegal or going to hurt someone. But even then, sometimes people do it, right? So the important equations that we need to know. I don't know what this clunkiness is. Here is the table that I would use, okay? So if I'm given an H plus concentration, can I find the pH? Yes, I follow the arrow. The pH is equal to the negative log of H plus. You see how this little table works? If I want to find the OH minus concentration, I follow the arrow. OH minus equals 1 times 10 to the negative 14 divided by H plus. That'll give us the OH minus. Notice that to go from H plus over to POH, it's going to be a two-step problem. You can either use this equation to find OH and then go down and find the negative log of that, or you can go from H plus directly to pH and do 14 minus pH. So me personally, these two things over here are always a little easier. So I'm always going to like convert it straight to the P whatever and then go over to whatever I need to do. Okay? Any questions on this? Yeah. So that's what this slide's showing us right here, right? So if we want to do, so that in that problem, we had an H plus concentration. We found the pH of it to get the pH. And then to find the POH, we just did the 14 minus that. So this slide shows that thing that we're talking about, right? What we just said. So does that make sense? So if I was making a cheat sheet, I would probably write this on there and I would maybe color code it so I don't get confused because sometimes we have a hard time following arrows, right? We're like, oh, I accidentally used this equation because I couldn't tell that this arrow was pointing the opposite direction. You wouldn't believe the excuses that I hear, okay? Most of the excuses I make up are made out of realness, all right? But to protect the talker, I changed my voice into little kitten. Just kidding. So we talked about KAs, right? When did we talk about KAs? When did we talk about KAs? Anyone remember? What was the take-home message of KAs? Yeah, Kobe? The larger the Ka value, the stronger the acid. Was it on these slides that had the Ka values? Maybe. Let's see if I can find. Okay, yeah, here they are. So what do you notice about these Ka values? All of them are what? Numbers times 10 to the negative something. Do you all like writing numbers that are times 10 to the negative something? Do you ever make mistakes when you punch that stuff into your calculator? Yes? I mean, sometimes, right? So what we can do is instead of reporting things in terms of Ka, what about something like pKa? Let's see if anybody can figure out how we would solve for the pKa of something. Zeus, any guesses? If pH was the negative log of H plus and pOH was the negative log of OH, what could pKa be? Anyone? Negative log of the Ka value. So what we do is if we take the negative log of a Ka value, let's find the pKa of benzoic acid. Okay. Benzoic acid has a Ka of 6.5 times 10 to the negative 5. Someone do the negative log of 6.5 times 10 to the negative 5 for me, please. It should be either in the 4s or the 5s. 4.2. Huh? Okay, well, we'll just do it like that. Someone take the pKa of 1.1 times 10 to the negative 2. So if this has a pKa of 4.2 right here. Let's find the pKa of the strongest acid, chlorous acid. Negative log of 1.1 times 10 to the negative 2. What does that give us? How much? 2 point something. What? 1.9? Okay. Someone find the pKa of 1.3 times 10 to the negative 10. $9.8. Okay, so what do we notice about? So what did we say with Kas? The larger the Ka, the stronger the acid. So this was the strongest acid, right? And this was the weakest of these all weak acids. So how are pKa's related to acid strength in this case over here? Any thoughts? The lower the pKa, the stronger the acid. Okay, so now that we see this, and I mean, like, just think about this. Would we want to talk about like all of these values with these numbers, like 1.1 times 10 to the negative 2, 6.5 times 10 to the negative fifth, 1.3 times 10 to the negative 10? Or would we like to say chlorous acid has a pKa of 1.9? Benzoic acid has a pKa of 4.2. Phenol has a pKa of 9.8. It's giving us the same information. Which number are we more happy using, Janessa? Which one would you rather use? The pKa value or the Ka values? The pKa, right? It's like whole numbers that are easy to like wrap our heads around. So basically, this is showing us that P whatever basically just tells us the negative log of whatever it is that we're trying to find out. So with Ka values, the stronger the acid, the smaller the pKa. Since a large Ka means a stronger acid, that means a smaller pKa means a stronger acid. Everybody comfortable with that? That's because it's a negative log of it. There's also a thing. Okay. Um, the larger the Ka, the larger the Ka means stronger acid, but that also means a smaller pKa, since the negative log of a bigger number gives you a smaller number. Okay? Does that make sense? So when we're thinking about these things, we're just thinking about, like I said, you can think about things in Ka, but they're all tiny numbers. You can think about things in Kas, and it makes everything be whole numbers. Okay? What other type of things use logarithms? Anybody know? We're in California. This is something that's important. What is it? What's the biggest problem in California? Huh? Earthquakes, right? You ever hear of the Richter scale? So when you have an earthquake of 6.0, it's pretty big, right? When you have an earthquake of 5.0, it's actually 10 times larger or 10 times stronger. So when you have earthquakes, when someone has like a magnitude 8 point something earthquake, that is over 100 times more shaking than a 6 point something earthquake. If you're at an 8.0 versus a 6.0, that's actually 100 times stronger. So that's how the log scale works. I mean, like I said, I'm not a mathematician, but just to give you an idea, when someone's like, "Oh, it was an earthquake 7," that's not a big deal. It's like, have you ever been in an earthquake? They're like, "Yeah, I was in a 5.5. It's only 1.5 difference." Well, that's actually 15 times stronger or more. I don't know. I'm not that good at math, even though I am. So there's also things called PKBs. So do we even know what a Ka is? What did we say a Ka was? It's the acid ionization constant. So K equals products over reactants. An acid dissociates HA, dissociates into H plus and A minus. So the equilibrium of this would be products times reactants. I mean, products times each other over reactants. Technically, water's involved in here, but it's a liquid, so we don't use water. And since this is specific for acids, we call it a Ka. Yes, constant. So the Ka value is the acid ionization constant. Okay, so those numbers that we saw, the bigger that number means the stronger the acid, means the more products it releases, right? So if you have that top number being bigger, that's why, and all of those numbers are all in the decimals because weak acids don't dissociate that much, right? They're not strong acids. When we talk about KBs, a base usually reacts with water to accept a proton, and when it accepts the proton, water becomes OH minus. So the KB value is the BH plus times OH minus over the base concentration. Okay, so we haven't got into KBs yet, but it's exactly the same as Kas. It's just the opposite end. The acids dissociate, the bases receive. Okay, so when we're talking about KBs, a larger KB means it's a stronger base. It's more willing to accept the proton. The larger the KB is, the stronger base. That means the smaller the pKb, the stronger the base also. Okay. So looking at these pKa's, which is the strongest acid on this list? Emily. Acetic acid or perchloric acid? Which of these is the so I mean it's not going to be anything in the middle, okay? So if I gave you this question on a quiz, what is the strongest acid of these? So you're picking the thing with the highest pKa. Is it highest Ka is the strongest acid? And how did pKa relate to Ka? The negative makes it the opposite, right? So thus we want the smallest value. Somebody chatted something. Very good, Emma. A voice is worth 1,000 chats, though. When we speak, everybody can hear. When you chat, only the invisible world of Zoom can hear. So come to class and talk, everyone. So what's your thought? You think it's perchloric, Emily? Why? But I'm not giving you any Ks. I'm giving you pKs. So restate that. Yep. So the larger pKa's means smaller Ks. That means the weakest acid is on the top. So these are the weaks. And these are the strongs. And actually, we said all of these were strong acids, right? Notice how they all have super low pKa's, meaning that they have very large Ka values. If all of these dissociate 100%, how can they have different values? That's a question I always asked. And I guess they don't really completely dissociate. They're just like one's 90, this one might be like 99.9999999%. This one might only be 99.999%. And the other strong acid, nitric acid, might only be 99.99% or something like that. Okay. So, but in general, all of those pretty much completely dissociate, right? So they're all strong acids in that sense over there. Okay. That is the end of this PowerPoint. Let's jump into the next one because it is what we're going to be doing in lab next week. It's gonna, I'm like, all of this was like just calculations. Let's do some fun. What do we miss from the exam? Ice tables, right? We can never get enough ice tables. So let's And guess what? If you did bad on the last exam on ice tables, you have a chance to redeem yourself. The next two chapters are all this same crap, probably just a little bit harder. So if you did bad on it, don't just like get upset at yourself for not knowing it. You have more time to learn it. It's perfect, right? If you're supposed to go to Portugal in the summer and you were planning on learning via Duolingo, but you didn't learn, are you not going to go to Portugal? Or are you going to go and just try and still learn it? I don't know. I'd go. Everyone speaks English. So we're going to just try and force ourselves to learn this, okay? So when we are trying to calculate the amount of H plus or a pH of a solution, we have to think about what are our sources of H plus that are present in any solution, okay? So if any of the sources are present in a much, much lower concentration, they can be considered negligible. What does that mean? That means that when me and my wife do taxes, anybody do taxes in here? Let me tell you, that was a crappy day for me, okay? So in about 10 days, I need to make sure I have a bunch of money because I owe a crap load of federal taxes, okay? But when I did my taxes, I put my salary and I put my wife's salary. My son made a little bit of money. Do I count the $37 he made selling soccer cards to my general income for my family? What do you think? Why not? And what does almost nothing mean? Negligible. I don't know why it says not eligible. That's stupid. But so negligible, so it's not eligible to be counted. So if me and my wife made more than that and my son made a little bit, do we have to add that into our total amount? No, we don't, right? Something is negligible, you do not need to count it because it's so small. So if we're looking at the sources of H plus in a solution and we've taken an acid, which puts in a crap load of H plus, and then do we still have to account for that 1 times 10 to the negative 7th molar of H plus that water donates from the autoionization of water? No, that amount of H plus that water always gives to the solution is negligible compared to the amount that everything gives, right? It's kind of like what we said if I was to see two people on the street and I was feeling generous and I wanted to give someone $20 and one of those persons was Elon Musk and the other person is someone who's living on the streets, who's going to appreciate the money more? Elon Musk, he wants every dollar he can get, right? That's why he's like doing everything he's doing. I don't follow anything. I just read headlines. So when I make any comment about anything that is like political, it's only from zero research, okay? I'm a scientist and I might look up some science stuff. I don't give a crap about politics, but I like to like poke the bear. So I read stuff from what I hear, but you know, I'm sure if I focused on it, the world would all get better. So when the world falls to turmoil, blame one person. No, it's everyone. But in general, right? If you have billions of dollars, $20 is insignificant. But if you have no money, then $20 is very significant. So sometimes we make things negligible. We've done this before when we did the assumption on the ice tables, right? So we're going to think about that same thing when we're doing this stuff. So if we wanted to calculate the amount of, so let's look at a strong acid, okay? If we have a strong acid solution, that strong acid HA is going to dissociate to give H plus and A minus. Whether it's a strong or weak acid, it's going to give a pretty significant amount. Water is going to autoionize to make a tiny bit amount. This 0.000000000000000 1 molar that adds, is that significant to the maybe 0.0345 molar something else might add? Do we have to add this 0.001 to that? That is negligible, right? So whenever we start these problems, that's going to be the kind of things we think of. If we're looking at a base, same thing. A weak base, ooh. If there's a weak base, actually, that's the end of class. So we'll continue with this on Monday, but the same thing happens with bases. Those form OH minus. That's how we'll solve for that. I will see you all on Monday. Have a wonderful weekend. all 500 of you on Zoom. I'm going to use a different one just to make life crappy for you. Aloha.